So single plate clutch having one pair of contacting surface. That means it has two contacting surface for a single plate clutch, and that is used for transmitting 15 kilowatt power. So the power is 15 kilowatt at 1500 rpm. Okay, the rpm n is 1500. Coefficient of friction mu is given 0.35. The permissible intensity of pressure not to be exceed zero point 0.6 Newton per mm square or zero point 0.6 megapascal. So the permissivity of pressure not to exceed, that means that is the maximum pressure. The maximum pressure is zero point 0.6 megapascal. Outer diameter of the clutch is also given 300 mm. We have to determine the clutch dimension by using uniform wear theory. Okay, so let's look at the solution part. So I have written all the given condition. Okay, we already know this is a single plate clutch. We already know, okay, it's a single plate clutch. Then the power, it's also given as 15 kilowatt. Then rpm, the mu, all the thing already discussed. The outer diameter is also given d of 300 mm. So first thing, in order to solve a single plate clutch, this will be the equation we'll be taking to solving. E is equal to 1 by 2 mu into n dash FAW into DMW. This equation is in the data book. So first we need to find each term distinctively. So this FAW means the axial load. So this is the equation to find this. Okay, here we know the maximum pressure, but we don't know DI, but we know DO value, we don't know the inner diameter. Okay, so solving the remaining part, we will get reduce as this. You can substitute the DO value right from here, or you can substitute it later. Next term you need to find is DMW, the mean diameter. That will be the mean of that will be mean of the two diameter, that is outer diameter and inner diameter sum by 2. We know the outer diameter, still we don't know the inner diameter. Okay, next term we can find is torque. Torque is always found by using this equation 2 pi nt by 60. We have the power, so substitute all the value, but one thing you have to look is you have to substitute the power in watt, not kilowatt. But in the question it is given in kilowatt, we have to substitute in watt. So 15 kilowatt has to be converted into 15 into 10 raised to 3 watt. You can see here all the remaining thing is same as that given question. So the torque will be, we will be getting in Newton meter, because we have converted into standard value, right? We have converted the kilowatt into watt, so everything is standard SI unit. So obviously the torque will be in standard value Newton meter, but we need the value in Newton mm. So Newton meter to Newton mm, just multiply by 1000. So now we have torque. Next part is simply substitution of the given condition, the given equation. So we expressing in only in terms of di, because we know all other terms. Okay, so it's a little bit, we just have to substitute. It's a little bit tough quadratic equation. So we'll be getting a quadratic equation. Later we'll be having a cubic equation. This will be the final equation based on the solving diq minus 90,000 di equal to this much value. So your di square or degree 2 term is missing. So when you solve this problem, you have to substitute it as 0. By solving will be, obviously this is a cubic polynomial, cubic equation, so we'll be getting 3 solution. One value will be negative, it cannot be taken because diameter cannot be negative, and the other there will be 2 positive value, but we only take the larger positive value. So the suitable value based on that will be 296.93 mm. Okay, that's the inner diameter. We can like round off to 297, or you can simply put it as 296. So that's the clutch dimension. Now we have outer diameter, inner diameter. Next thing we have to determine is the axial force FAW. So it's a way to find the axial force. This equation. Also, you can find the data book. This equation we already taken earlier, but then we don't have the value of di. Now we have the value of di. So again substituting, we get the axial force FAW. So this is the way to solve this problem.